first thing we have here is this parameter n equals 3. No particular reason, it's just a constant, just like you can have constants in any programming language. So for scalability, if you needed to change this at some point and make it not 3, you could do that. And then we've got our inputs, VW side 0 clock. And here this Q is a reg, so we know we're changing it inside an always block. And it's a vectored signal. And you can tell that by these square brackets on it. And that tells you how wide it is. And so this is saying Q. So since n is 3, this is 2:0 is Q. That means that it's 3 bits wide, 0, 1, 2. That means I have Q0, Q1, and Q2. And I can access those individually, or I could access the entire thing as a 3-bit number. I don't in this problem, but you will see it in other problems. I have an output. That's side 1. Notice that output is not listed as a reg, so we must be assigning that outside of an always block. We've got an integer k. It's going to be, for now, you're probably just going to see those used for your for loops. And so we've got that going on. And then we have our always block. And it says always at the positive edge of a clock. So this tells us that we've got something happening at the positive edge of a clock, and something's going to happen at that positive edge of the clock, and we'll take a look at our for loop to figure out what it is. So what exactly is going on. So first of all, I'm going to say since n was equal to 3, this is 2. So n minus 1 is 2. So for k less than 2, so this means k equals 0 or k equals 1. And then if v, then q of k becomes q of k plus 1, else q of k becomes w or q of k plus 1. Or is that an exclusive or? Hold on just a second. Okay, so we have, when you see a setup like this, we can implement it using D flip-flops. And we've got Q0, Q1, Q2, so I'm just going to label these 2, 1, 0. And the Q would be the output from these. So the output from this one is going to be Q0, or Q2. The output from this one would be Q0, and the output from this one would be Q0. Okay, so it says if V, then we're going to say we're starting this as a for loop, so we're starting with k equals 0. So if V is 1, then Q of 0 becomes Q of 1. So I'm going to put a little multiplexer up here. Because ifs often mean multiplexers. And V, the variable V, is going to be my input to my multiplexer. And my multiplexer has 0 and 1. And if V is 1, then my first time through this for loop, k is 0. Then Q0 becomes Q1. So my output from Q1 goes into Q0. These are D flip-flops. If instead V is 0, then Q0 becomes the exclusive OR of W and Q of 1. So I've got an exclusive OR I couldn't be any messier. There we go. Okay. So that, let's see, and that is my for loop. So now I go back. So that was with k equal to 0. Now with k equal to 1, I have another multiplexer here, and V is my signal for that one as well. And now k is 1. And if V is 1, then Q1 becomes Q2. So Q2 is going to be going into the 1 of that multiplexer. Else, Q1 is the exclusive OR of W and where did I put W? Oh, I never did my W. So W. So then I have my exclusive OR of W. And that is going into the 0. Sorry, that's so messy. Okay, and now we're done with our for loop. Now we have Qn minus 1, so that's Q2 becomes side 0. So side 0 is just a variable that's going into there. And then we're out of the always block altogether, and it says assign side 1 to Q0. So this is side 1. Oh, it's not in the recording. That's side 1. So each of these Qs can be represented with a D flip-flop. And this has the non-blocking assignment. And what that means is, rather than putting an equal sign here, we used this less than sign and an equal sign. And we did that because we wanted these to use the values that the variables had when we went into the always block. If we just put equal sign, every time one of these changed, it would use that new value. But we don't want to do that. This is a register. We want everything to happen. We don't want things to be continually changing. We want it to change once at the positive edge of the clock, and then once things have settled down, not change again. So that's why we're going to be using that non-blocking assignment. Okay, so questions on that one?
How did you know the value of V?
I didn't know the value of V. I knew V could be 0 or 1. And so since it said if V, that was my signal that I needed a multiplexer. The if tells me I need a multiplexer. V is going to be the input. And then if V, so it says, but to answer your question, so if V, that means, that's the shortcut for saying if V equals 1, do that line. And then else is if V equals 0. So we do have to take care of both possibilities. Other questions?
How do you know which data info is going into?
The V?
No, like the 0 or a 1.
Okay, so I'm going to look at the situation where it's my first time through the for loop. And my first time through the for loop, k is 0. So k equals 0. And so when I'm looking at this line right here, or that group right there, k is equal to 0. So I can summarize that and say if v equals 1, then q of 0 is equal to q of 0 plus 1. Else, which is the same as saying that means v equals 0, then q of 0 equals the exclusive OR of w and q of 1. So this was my first time through the for loop where k was equal to 0. So if I just fill those things in, that's my first time through the for loop, I replaced my k's with zeros, and that's what it's telling me to do. So I've got a D flip-flop that's representing Q1. My output for this one is Q1. And I've got a D flip-flop, and the output for this is Q0. And this if tells me I'm going to need to have multiplexers. I might not know how many I'm going to need to have at this point. Right now I'm dealing with Q0, so I put one over here at Q0. And I've got a 0 and a 1, which are my two possibilities for a 2-input mux. And V is what tells me which of these I'm going to use. So V is my variable that goes into it. Sometimes you draw it above, sometimes below. And it says if V is 1, then Q0 needs to be Q1. That means that if V is 1, I have to have Q1 going into the 1 because the V is 1. And my output here is Q0 because this I'm defining what Q0 is. This whole part is defining what Q0. Don't do that to me. Don't do that. I was being brilliant. Okay. So, so when V was 1, I needed Q1 to go into the 1 of the multiplexer. Now, when V is 0, that tells me I need the exclusive OR of W. So I've got W and the exclusive OR of Q1, and that's if V is 0, and so that's what goes into the 0. Does that answer the question? Okay. Other questions?
So if you had if you had labeled it, it would have been like shifting towards like if you had labeled it 0, 1, and 2, going to the left and right, then you should. And what does that say by side 1? Like you have like side 1 and then 5.
Oh, I rewrote it because I realized that was outside my recording screen. It's just side 1. The variable is named side 1. So it's just, so the output is side 1. What about the clock? I should have drawn the clock. I did not draw the clock. I should have drawn the clock.
Where would it go?
So it would be, you would put here, here, and you would do clock, and you would have a signal that goes into each of the clocks. Yeah.
But does that mean at the same time? Okay.
Yes.
So if it doesn't say, we just assume that it's asequence?
No, well, we have clock as an input.